How did Vikings turn milk into food that never spoiled? In the frozen darkness of a 9th century Scandinavian winter, where temperatures plunge below freezing for months and fresh food becomes a distant memory, a Norse family gathers around their longhouse hearth. Outside, snowdrifts pile against turf walls. Inside, wooden barrels line the earthen floor, filled with dairy products that have remained edible for months, some even years. No refrigeration, no chemical preservatives, no modern technology. Just milk, transformed through methods so effective that food remains safe to eat long after it should have rotted. The Vikings didn't just survive these impossible conditions, they thrived. But the Vikings had a system, one built on understanding bacterial fermentation, strategic fat manipulation, and environmental engineering that modern food science is only beginning to fully appreciate. The challenge facing Viking Age communities was extraordinary. Archaeological evidence from settlements across Iceland, Norway, and Sweden reveals societies dependent on livestock for survival, particularly dairy animals. Research indicates that a large Viking Age farm in Iceland maintained between 20 and 40 milk cows, along with substantial numbers of sheep and goats. These animals produced abundant milk during summer months. But that abundance created a critical problem. Fresh milk spoils within days, even in cool climates. Winter stretched 6 months or longer in northern settlements. The mathematics of survival were brutal and unforgiving. Communities needed to preserve the nutritional value of thousands of liters of summer milk to sustain them through winters when animals produced little or nothing. Failure meant starvation. Success required transforming liquid milk into stable, long-lasting food products that retained their caloric and protein content across seasons. The first transformation Vikings mastered was skyr, a cultured dairy product that represents one of humanity's earliest applications of controlled bacterial fermentation. Historical records and archaeological findings from Iceland indicate that skyr production began with heating skimmed milk to approximately 70 degrees Celsius. This heating served multiple purposes. It killed harmful bacteria that could cause spoilage or illness. It altered milk proteins in ways that improved texture in the final product. It created optimal conditions for beneficial bacteria to thrive. Once heated, the milk was cooled to roughly 37 degrees Celsius, a temperature carefully chosen because it matches the ideal growth conditions for specific lactic acid bacteria. Vikings then added their starter culture, typically a small portion of skyr reserved from the previous batch, ensuring continuity of the bacterial strains across generations. This practice of maintaining living cultures represented sophisticated biological understanding. The bacteria employed were primarily mesophilic lactic acid bacteria, including strains similar to modern Streptococcus thermophilus and Lactobacillus delbrueckii, subspecies bulgaricus. These microorganisms consume lactose, the sugar in milk, and produce lactic acid as a metabolic byproduct. The lactic acid performs the preservation work. As acid accumulates, the pH of the milk drops significantly, creating an environment hostile to spoilage organisms and pathogens. Most harmful bacteria cannot survive in highly acidic conditions. The lactic acid bacteria essentially claimed the milk as their territory, crowding out competitors through chemical warfare. After bacterial cultures were established, Vikings added rennet, an enzyme complex extracted from the stomach lining of young calves. Rennet causes milk proteins to coagulate, forming solid curds that separate from liquid whey. The curds were then strained through cloth, removing excess moisture and concentrating proteins. What remained was skyr, a thick, creamy product with the consistency of modern Greek yogurt, but technically classified as a fresh cheese due to the rennet usage. The final product contained extremely low moisture content, which further inhibited bacterial growth. Skyr could be stored in cool conditions for months without spoiling. Its high protein content, approximately 11 grams per 100 grams, made it nutritionally valuable. Its tangy flavor, a direct result of lactic acid, added variety to the Viking diet. Archaeological evidence from Viking Age house sites, including the farm at Stong in southern Iceland, reveals large wooden vats partially set into the ground, specifically designed for storing dairy products like skyr. But the Vikings didn't discard the liquid whey separated during skyr production. This represented their second major preservation innovation. Whey contains lactose, water-soluble vitamins, and trace proteins, making it too valuable to waste. Vikings allowed whey to ferment further, producing what historical sources call súrr, or sour whey. This fermentation continued the lactic acid production, creating an even more acidic liquid. The pH of properly fermented whey drops below 4, approaching the acidity of vinegar. At this acidity level, whey becomes a powerful preservative agent. Vikings discovered they could submerge cooked meats in vats of sour whey, and the meat would remain edible for extended periods. The lactic acid prevented the growth of Clostridium botulinum, the bacterium responsible for deadly botulism. It inhibited other spoilage organisms. It created conditions where properly prepared meat could last months. Archaeological excavations at Viking Age farms have uncovered these large storage vats, with organic residue analysis confirming their use for whey preservation. The reconstructed dairy vat at Stong measures approximately 1 meter in diameter and half a meter deep, capable of holding hundreds of liters of liquid and preserved meat. Historical Icelandic sources reference this preservation method continuing into modern times, with sour whey used to preserve traditional sausages made during autumn slaughter. The technique represents elegant efficiency. Milk becomes skyr for direct consumption. The byproduct, whey, becomes a preservation medium for meat. Nothing is wasted. Every component serves survival. The third transformation Vikings perfected was butter production and its subsequent preservation through bog storage. Butter making began with allowing fresh milk to stand until cream naturally rose to the surface. This cream was skimmed off and collected over several days. Once sufficient cream accumulated, it was agitated vigorously in wooden churns until fat globules coalesced into solid butter, separating from liquid buttermilk. The butter was then washed repeatedly with cold water to remove residual buttermilk, which could cause spoilage. The resulting product was nearly pure milk fat, with moisture content below 16%. This low moisture content provided inherent stability, but Vikings took preservation further through a practice documented in over 430 archaeological finds across Ireland and Scotland, regions with significant Norse settlement during the Viking Age. They buried butter in peat bogs. The practice, known as bog butter preservation, involved wrapping large quantities of butter, sometimes 20 kilograms or more, in wooden containers, bark, or animal bladders, then submerging these packages deep in peat bogs. The bog environment provides unique preservation conditions. Peat is highly acidic, with pH levels between 3 and 4. This acidity inhibits bacterial and fungal growth. Peat bogs are anaerobic environments, lacking oxygen necessary for many spoilage organisms. The temperature remains consistently cool, typically between 4 and 10 degrees Celsius year-round. The combination creates nearly perfect conditions for long-term fat preservation. Archaeological evidence reveals bog butter samples, radiocarbon, dated to between 5,000 and 1,000 years old, some predating the Viking Age, but demonstrating continuity of the practice. Whether Vikings intended bog burial for preservation, ritual offering, or a combination remains debated among scholars. However, the effectiveness is undeniable. Butter stores this way could remain stable for years, potentially decades. Some researchers suggest the practice also altered butter flavor, creating a cheese-like taste that Vikings may have preferred. The technique demonstrates sophisticated understanding of environmental engineering. Vikings recognized that natural landscapes, specifically peat bogs, could function as food storage technology. The fourth dairy preservation method involved creating aged cheeses through extended fermentation and drying. Historical sources reference skyr, a product made from skimmed milk, rennet, and extended aging. Evidence suggests Vikings allowed this cheese to ferment for at least 2 years before consumption. Extended aging serves multiple preservation functions. Moisture content decreases through evaporation, creating increasingly inhospitable conditions for microorganisms. Salt content becomes more concentrated. Beneficial bacteria and molds develop protective rinds. The cheese develops complex flavors and harder textures. Archaeological finds of cheese-making equipment, including wooden molds and pressing stones, confirm Vikings produced various cheese types beyond skyr. The long aging periods indicate sophisticated appreciation for how time transforms dairy products. 2-year aging requires planning and resource management. It requires storage spaces with appropriate temperature and humidity control. Viking longhouses, with their cool, slightly humid interior environments away from the central hearth, provided suitable aging conditions. The practice also required cultural continuity, with knowledge of cheese-making techniques passed through generations, typically from mothers to daughters. Historical records indicate women primarily managed dairy production in Viking Age society, making them the keepers of this crucial preservation knowledge. The science underlying these preservation methods reveals why they worked so effectively. Lactic acid fermentation creates multiple preservation barriers simultaneously. The acid itself acts as an antimicrobial agent. The fermentation process consumes nutrients that spoilage organisms would otherwise use. Beneficial bacteria produce bacteriocins, protein compounds that specifically inhibit competing microorganisms. Some lactic acid bacteria produce hydrogen peroxide, another antimicrobial compound. The combination creates what food scientists call hurdle technology, where multiple preservation factors work together, each adding another obstacle that spoilage organisms must overcome. The hurdles prove insurmountable for most pathogens and spoilage microbes. Modern research into lactic acid bacteria confirms their effectiveness. Studies demonstrate that lactic acid shows greater antimicrobial efficiency against gram-positive bacteria, with increasing effectiveness as acidity rises. The bacteria Vikings cultivated in their dairy products were performing sophisticated biochemical work. They were converting milk sugar into organic acids. They were producing antimicrobial peptides. They were creating biofilms that protected fermented products from contamination. Vikings couldn't see bacteria or understand microbiology in modern terms. But through careful observation and experimentation across generations, they developed processes that harnessed bacterial power for survival. The nutritional implications of Viking dairy preservation deserve examination. Modern nutritional analysis of Viking age diets, conducted using period-appropriate foods and portion sizes, reveals how crucial preserved dairy became for survival. Fresh milk provides calories, protein, calcium, and B vitamins, but these nutrients must be preserved through storage. Skyr, with its concentrated protein content and reduced moisture, delivers approximately 110 calories per 100 grams, with 11 grams of protein and minimal fat. For Viking populations consuming 3,000 to 10,000 calories daily, depending on season and activity level, Skyr provided high-quality protein in compact form. Butter provided concentrated calories from fat, approximately 717 calories per 100 grams, crucial for meeting extreme energy demands of Viking life. Aged cheeses provided both protein and fat in shelf-stable form. The whey used for preservation retained water-soluble vitamins, including vitamin C in small amounts, potentially contributing to scurvy prevention during winter months when fresh plant foods disappeared. Archaeological analysis of skeletal remains from 11th and 12th century Iceland, specifically from Skeljastadir in Þjórsáralur, shows little evidence of nutritional deficiency diseases. This suggests Viking preservation techniques successfully maintained nutritional quality alongside food safety. The broader implications of Viking dairy preservation extend beyond mere survival technique. These methods represent empirical food science developed without microscopes, thermometers, or written chemical formulas. Vikings understood that milk, left in specific conditions, developed beneficial sourness rather than dangerous spoilage. They recognized that this sourness could preserve other foods. They discovered that removing moisture increased storage life. They learned that cool, acidic, oxygen-free environments prevented decay. Each discovery built upon previous knowledge, refined across centuries, tested by the ultimate measure of whether communities survived winter. The knowledge was encoded in practice rather than written instruction, passed through apprenticeship and family tradition. The maintenance of bacterial starter cultures across generations represents a form of biological inheritance, carrying forward specific microbial strains selected for their preservation properties. When Vikings settled Iceland in the late 9th century, they brought their dairy cultures with them, Those bacterial lineages have survived over 1100 years, maintained in continuous chains of skyr production extending to the present day. Modern Icelandic skyr producers use bacterial cultures descended from those original Viking Age strains, an unbroken biological link spanning millennia. The environmental intelligence displayed in bog butter preservation reveals sophisticated landscape knowledge. Vikings recognized that certain environmental features, specifically peat bogs, possessed preservative properties. They understood these locations remained cool when air temperatures fluctuated. They observed that organic materials submerged in peat didn't decay normally. Whether through intentional experimentation or gradual observation, they identified a natural storage technology. This represents a mindset fundamentally different from modern industrial food preservation, which typically imposes preservation through applied technology, canning, freezing, chemical additives, irradiation. Viking methods worked with existing biological and environmental processes, channeling natural phenomena toward human needs. Fermentation harnesses bacterial metabolism. Bog storage exploits specific geological conditions. This approach required deep environmental knowledge, developed through generations of careful observation. It required understanding seasonal patterns, microbial behavior, before microbiology existed as a science, and the properties of different landscapes. The knowledge was practical, tested, refined through immediate feedback. Methods that failed led to spoiled food and potential starvation. Methods that succeeded were preserved and elaborated. The cultural significance of these preservation techniques extended beyond their practical function. The ability to transform perishable milk into stable, long-lasting foods represented mastery over environmental limitations. It enabled Norse expansion into marginal environments, including Iceland and Greenland, where growing seasons were minimal and survival depended heavily on animal husbandry. Without effective preservation, these settlements would have been impossible. The techniques also created social structure. Dairy production was primarily women's work in Viking Age society. Women managed the animals during milking, controlled skyr production, maintained bacterial cultures, and oversaw storage. This created a domain of female expertise crucial to community survival. The knowledge of when to harvest cultures, how to judge proper fermentation, and how to manage storage was specialized knowledge that commanded respect. Some scholars suggest that the value placed on this knowledge contributed to the relatively higher status of women in Norse society compared to other medieval European cultures. The woman who could maintain healthy dairy cultures and manage food stores through winter held tangible power within her community. So when we ask ourselves, how did Vikings turn milk into food that never spoiled? The answer emerges as a complex system built on multiple interrelated techniques. They transformed fresh milk through controlled lactic acid fermentation, creating skyr that concentrated nutrients and generated preservative acids. They repurposed the resulting whey, fermenting it further into a powerful preservative medium for meats. They separated milk fat into butter and stored it in peat bogs that provided natural refrigeration and antimicrobial conditions. They produced aged cheeses through extended fermentation and moisture reduction. Each method addressed different aspects of the preservation challenge. Each exploited different biological or environmental mechanisms. Together, they created a comprehensive preservation system that sustained Norse communities through impossible conditions. These weren't primitive or simple techniques. They were sophisticated applications of principles that modern food science has only recently begun to fully understand. The Vikings didn't have laboratories or textbooks, but they had something equally valuable: generations of accumulated observation, experimentation, and refinement, tested against the ultimate standard of survival. Their milk never spoiled in literal terms, but through systematic transformation using fermentation, acidification, dehydration, and environmental control, they extended its useful life from days to months, sometimes years. They turned summer abundance into winter survival. They transformed liquid vulnerability into solid security. And in doing so, they demonstrated that human ingenuity, careful observation, and deep environmental knowledge could overcome seemingly insurmountable challenges. The legacy of their methods survives not just in archaeological sites and historical records, but in living practice, in the bacterial cultures still fermenting Icelandic skyr, in the continued use of whey fermentation in traditional Nordic foods, and in the growing modern appreciation for fermentation as both preservation technique and culinary art. The Vikings solved the challenge of turning milk into food that never spoiled, not through a single breakthrough, but through a comprehensive system of techniques, each building on biological and environmental realities, refined across centuries, and proven effective by the survival of Norse civilization across some of the harshest environments humans have ever inhabited.